Hello everyone, welcome to CAD Nest. This is Angsa. Today I am going to explain about isolated footing. It means one of the most used types of foundations to support single column when they are arranged at the long distance. For example, a pad or flat isolated footing is constructed by plain or reinforced concrete. Its thickness is constant and its shape can be circular, rectangular or square. This is called as isolated footing. Okay, let's start our project. For that I am going to start draw. Here select the new project option. Then the rename as isolated footing. Then select here space option, then meter and kilonewton. Next, just I am going to structural wizard option, then finish. Then go here, select the frame model. In that I am selecting wayframe option. The default values are this is only I am going to use. Then apply, see the model, then close. Would you like to transfer or merge into phototype? To start draw? Yes. Then we need to place at the 0, 0, 0 axis. That's what. Okay. See, model is ready. Then go to general. For that, go to define. As you select the rectangular beam for that 0.4 cross 0.4. Then material is concrete. Add. Similar. The beam size is 0.3 and then pinch 3. Add, close. I just select the column. For that go to select beams parallel to Y. Assign to selected beams. Assign yes. Then select the beam. For that go to select beams parallel to X and beams parallel to Z. Assign to selected beams. Assign yes. Then go to supports. Select create option. In that I am selecting the fixed support. So add. Then select the fixed support. Go to front view. Select all the bottom nodes. Then go to 3D view. Assign to selected nodes. Assign yes. And then go to loads and definition. Here I just applied the dead load and live load. In that I am selecting the dead load condition. The title as DL. Add and then live load. That is I renamed as live load. Add, close. Then select the dead load. Go to add. In that dead load means self-height of the member. Just I assumed as 1. That is towards downward direction. That's what -1. Add, close. Then live load. Add. In that I am going to select the member load under uniform force. I need to apply entire the structure. So -2 kilonewton towards global axis down. So that's what minus. Here I just give the D1, D2, D3 is 0. Add, close. Select the self-height of the member. Assign to view. Assign yes. Then uniform force. For that go to select option. Beam parallels to X. And then select beam parallels to Z. I just select assign the selected beams. Assign yes. See, the member load will be applied. Then select the material options. Material is already assigned, so no need to assign. Close this. Finally go to analysis and print options. In that performance analysis, no print, add, close. And then go to analysis, run analysis. Then save. Then go to post process mode. Done. Select both loads. Apply. Okay. Then again go to modeling. In that I'm going to select design option. For our structure is concrete member, so that's what I'm selecting the concrete. Here Indian standard IS 456, and then select parameters, drag this side. In that I'm selecting the compressive strength of concrete and yield strength of main reinforcement. Then OK. Define parameters. Here I'm just using the M20 plates of concrete. That's what 20,000 kilonewton per meter square. Add the steel as 415,000 kilonewton per meter square. Add close. Then command design beam. Add. Then design column. Add close. FC. Assign to view, assign yes. FY, assign to view, assign yes. Then design beams, go to select, beams parallel to X, and then beams parallel to Z. Assign to selected beams, assign yes. Then go to column, beams parallel to select, beams parallel to Y, assign to selected beams, assign yes. That's it. Again go to analysis, run analysis, save. Done. This model is assigned already. Now I'm going to use this model to run the isolated footing design. For that I'm going to select the foundation design option. I just select the both load conditions, include all, and then select this loads. Then run STAAD foundation. You just click inside of the screen and then scroll the mouse. See, this is our footing. Totally we have 65 numbers of, totally we have 125 numbers of footing. Then go here, see, job setup, just click the plus point. Here we have create a job option. In that, just go here, job name, isolated footing. Then go to select here. In STAAD Pro, we have default 4 methods of design. First one is isolated footing. I think you know already what is my isolated footing. In that, I just select the Indian standards for the design code. And then here SI units. And then select this both loads down. Then create job. It is created. See, it's created now. Now you just go to select the isolated footing. Then design parameters. Concrete and rebars. This is the concrete details. It means unit weight of the concrete and minimum bar spacing. It is completely depends on the Indian standards codes. If you need means you can change all the values. Then go to covers and soil. This is here I adopted drained conditions. If you need means you just select the undrained conditions. And then footing and geometry. This is our cross sections and detail specifications of footing. Then sliding and overturning. Coefficients of friction is 0.5. Factor of safety against sliding actually 1.5. Factor of safety against overturning is also 1.5. Then finally design. Do you want to analysis and design? Yes. See, our footing will be designed. We have totally 125 numbers of footing. So just select the footing number 1. This is our geometry of the number. See. Footing number 1 and that design. length of the column and width of the column, and then concrete and rebar properties, unit weight of the concrete and strength of the concrete, and the yield strength, and the maximum bar size and minimum bar size, and then minimum bar spacing and maximum bar spacing. Here as a soil property, I used drainage conditions, unit weight of soil, SBC, and soil surcharge, and depth of the soil above the footing is 0, and then cohesions, it is a cohesive soil, so, and then sliding and overturning. So just I show the details in scheduling. This is scheduling of our footing. Detailed drawing. See, our column sizes 400 mm cross 400 mm, and then top reinforcement and bottom reinforcement. Then this is column layouts. So that's it. This is a design procedure for isolated footing. Thank you for watching this session. Please subscribe and press the bell icon to get the updated notifications.